next speaker is Paul Betts from Slack, and he'll be talking about Electron. Give it up for Paul.
How's it going? So my name is Paul Betts. I work at Slack on the Slack Windows / coming soon to Linux app. And today I'm here to talk about single-page applications in Electron. And so really, not only that, just kind of giving the like Electron 101 class, how to build your own apps using Electron. So what is Electron? Electron is the C++ Chromium kind of platform that powers Atom, the text editor. So Atom, the text editor, is this application written in JavaScript and HTML and CSS using web technologies. And Electron is the Chromium C++ code that kind of powers it. So it's the place where you can write on top of it web code to write a desktop app. And it turns out that Electron is useful for not just writing a text editor, but it's a really great platform for writing all kinds of desktop applications. So we at Slack use it to write the Slack Windows application, which we shipped in March or so. And a lot of other people are using it to build all kinds of interesting things. A startup called Wagon is using it to build data analytics applications. There's this startup called Kitematic, which is using Electron as well. So Electron is this really cool platform for writing desktop apps. In JavaScript. So why is that cool? So for my entire career, I've been a native developer. I've written Windows applications and Mac applications in C# and Objective-C, and I was really hoping that this web thing would just kind of go away, you know, like just kind of blow over. We go back to writing exe files and everyone would be happy. But it turns out that writing native applications is really hard. And even if you're really good at it, it still takes a lot of time. And the web has done this really interesting thing in that you can do things so quickly versus writing native applications because of things like DevTools. DevTools is like the killer feature of like the web, in my opinion. It's this incredible like experimentation platform for writing applications. I'm probably like preaching to the choir like you're all writing web apps anyway, and you're like, of course we knew this a long time ago. And I'm like, mind blown. And anyway, it turns out that because everyone focuses on the web is actually one of the most interesting layout and rendering platforms in the world. It's the most like so many people, really smart people are focusing on how to make this layout and rendering engine on the web really fast. And so, but the like thing that native developers always like had an edge up on web developers was that web always had this like limit, right? There are certain things you just couldn't do in a native application. And so Electron is kind of the first really interesting platform to me anyway that kind of throws away all those limits. Like all the advantages that native developers had kind of went out the window because Electron lets us do all the things we could do on the web and then do all the things that desktop developers could do as well, which is really cool. So in the background, we can see this website called Chrome Status / Features. And so we can see all the new cool stuff that we can use in Electron. So one of the other cool things in Electron is that you're guaranteed that you're running the latest stable version of Chrome. So you can use features that like other web developers are just kind of waiting for. Things like the picture tag, the picture element to do device-independent scale bitmaps, or like this new cache fetch API to kind of override the browser's version of their network cache. So from a web developer perspective, you get to use all the new cool stuff, and you don't have to worry about supporting these old browsers. Electron is always the newest, coolest thing. Cool. So how does it work? How does Electron? How do I write my own Electron application? So we start off with io.js. And so one of the really interesting things about Electron is that it's Chrome and io.js 2.2.1, I think is of current writing, combined together. So in the Chrome run loop, we even put in io.js. But before we get to that, we start off actually with just io.js. So the entry point to an Electron application is just an io.js script. So you start off with a JavaScript file. We're going to run that file. And if we don't do anything else, then that's all that happened. So no DOM, no DevTools, no Chrome, anything actually. We're effectively the same as just if you type like node some script. So that's kind of the beginning of every Electron application. Chromium calls this the browser process, even though there's no browser. This is confusing. Chromium kind of picked the worst terms ever to explain what these are, but if you see the browser process, you have to know that there is no browser. So the browser process in Chromium does things like it manages the browser cache. It's the one that makes network requests. It is like the top-level process. So if you remember that Chrome has like this multi-process model. If you open up Task Manager and see like 15 atom.exes, that's why. All of them do different things. And the opening one, the one that starts your application, is called the browser process. So this is like the smallest Electron application we can write. So we have this class called app, and it's kind of our opening, our way to interact with Electron. It fires this event called ready. So Chromium kind of has to set some stuff up before we can do anything to do, right? Entire app. So where does Chrome come in? So there's a class confusingly called browser window, which will get you out of the browser process and into what is called the render process. So it's just a class, you just create it. Every single time you create a browser window class, you'll create a new process called the rendering process. And so browser windows are the way to create a window for our application. So to create a rendering process, we create a browser window inside the browser process. This is confusing. So in this syntax, I'm using the ES6 syntax. If that's a little confusing, then kind of don't worry about it. It's not, that part's not important. So we're going to import browser window and path. And when we're ready, we're going to create a new browser window and load a URL. And usually you load a URL that's a file URL because you've shipped some of your content with the application. So we're just going to load an index file that's in the same directory as my script. And we're going to share the window. So, and here we're going to kind of be a little bit lazy and just wait 5 seconds. And then we're going to open DevTools. So to open DevTools, unlike, because everything we control everything in Electron via our own code, there's just a method called open DevTools. So now we've got a window. And so we've got DevTools, we've got a DOM, we've got a console. Chromium calls this a render process. So we've got more than one process. And so in this, just like in our browser process, we have access to io.js. So I can set type require fs, write files, do anything I want. So one thing that's important that's a little bit confusing is that since there's multiple processes, now I can't just like access globals in one to the other. So like if I said like window.foo equals bar in my browser process, in this window it's going to be unset because they're separate kind of universes. And so there are ways to talk between these two using a module called IPC, which lets us send messages between them. Or there's this module called remote, which lets us actually create classes in other processes, which is pretty cool. It saves a lot of time. So one thing that's interesting about Electron is that it kind of lets you do whatever you want. A lot of web features that normally would, like popping notifications, you have to go through the dance of like request permission to pop a notification. You don't have to. It's hard-coded to yes, you can. Or like using the camera or the microphone or these kind of like permission-based APIs, they all just work because they're kind of, if you've downloaded a desktop application, you're kind of like, they can do what a desktop application could do. In your browser window, you're not restricted by really anything because you can include io.js modules. So anything you can install via npm, you can use inside your Chrome window, which is really cool, including using native modules, so modules written in C++. This really means that you can do anything inside an Electron window that a desktop application could. So that's super cool. So the Slack app is a little different than the way that Atom works. And so I'm going to kind of describe kind of two different ways to write desktop applications using Electron. So Atom has desktop Zen nature. So when you download Atom, all of the HTML, all the CSS, all of the JavaScript is shipped in the box. Atom doesn't know about the internet on startup. It executes everything from this app, from this bundle, essentially from file URLs. It's as if you had a folder full of HTML and you double-clicked on it and opened a page. So that's one way to write an application, and you can still do updates and things like this, and you're really thinking of it like a desktop application. Slack's a little different. The way that Slack works is it was originally designed as a website. And so we kind of built it to be this, the term we use inside of it is like a single site browser. So it's a little bit more like it's framing remote content. So you open the app, it shows a loading screen, and then it loads a remote page. So that has, we can update a website way faster than we can update a desktop application. Even though actually we can update desktop applications pretty quick too. So one thing that's really cool is you can kind of get the benefits of both. And I'm going to show how to do that. And really the core idea is that Electron lets us build a web browser that does whatever we want, which is cool, but it also lets us build a web browser that is wildly insecure. So if you're not careful, you can build a web browser that is like, like IE5 and can let users get hacked by remote content. Because you're loading content off the web, that could be really bad if they can access desktop things, which means they can access users' computers. So if third-party code gets a hold of node.js, we got big problems. And so in the Slack app, there are a bunch of, not only just like the straight up like people man in the middling Slack. Slack, when you, for example, drop in a SoundCloud URL or a YouTube link or an RDO link, they do what Slack calls an unfurl, where they will take it and embed content in the page that is from someone else. And so that someone else gets taken over. They could have access to Node.js, and if they have access to Node.js, they have access to the entire computer. So what do? Web view. So there's this feature of Electron that we use inside the Slack app to make sure that we can give the Slack web page kind of superpowers, but not allow it access to everything. And that feature is called Web View. And this was originally a feature of like Chrome packaged apps, like Chrome applications, that we kind of like ported/stole for Electron. It works similar, but not quite the same. So like if you read the docs for like Chrome package apps version of WebView, you'll be like, this seems familiar, but it's not identical. So WebView is like an iframe, but like a special iframe. So WebViews are, depending on how you configure them, of course, sandbox from io.js. It means that they cannot access node.js, or they cannot access, like, they can't do require, they can't say, process.versions, they can't do anything that you can access in io.js. They have normal web browser security rules. So cross-site scripting is disabled. All of the web security stuff that you're used to when building a web page is true inside WebViews. And so if you look at how the internal architecture of WebViews work, it's really like a Flash plugin. But instead of Flash, it's just another browser or render process that remotes its content to a frame. And so now we have three processes. We have the browser, we have the render, and we have a web view. So they can all talk to each other. But they all have their own global kind of scope. If a web view crashes, just like a plugin crashes, you can just restart it. So it's really like, it's this frame that you can do whatever you want. But that sounds like a bummer because then I can't, inside my web view, do any, like I'm just a web page. Like, how can I use my Electron superpowers? Web views give us an escape hatch, and it's called the preload script. And so the way that web views, you can set up web views is that when you go to navigate to a page, before it does any navigation, before it loads the DOM, before you even have a window object, you have nothing, we will run a script of your choosing, and that script will have access to io.js. It can do everything that it can require things, it can set up objects. And so you get to run that one script that can do anything it wants, and then the page will be navigated to. And then, like, access is cut off. You can't do anything anymore. When you run that script, there's no DOM. If you try to do like window.something, you'll fail. It won't work. Just your script. But this is the trick that makes everything work, is that one of the things you can do is you can set global variables, like you can set window.something, that will persist on the page once the page loads. So you can set up a bunch of things, set them to global variables, and they'll still exist when the page loads, even though web security is not enabled. This is the way that this is the thing that makes it possible. So in the Slack for Windows app, we just do this. We set up on window, we set up an object called Electron API, and then we just create all these things. And all these things do a bunch of requires, they capture a bunch of things, and because they have access to io.js, they can do whatever they want, and they set up this API surface. So essentially we define this like new set of browser APIs that our web app can access, but they can't access everything. We've decided what they can do and what they can't do. And we've created this security boundary that lets us feel secure that we won't get broken into or anything. So some pro tips. If you leak io.js objects via some kind of like just leave them set on a variable, that means that somebody can access them. So if you set like fs to like a property on one of these objects, then the web app can access them. That's bad. Debugging preload scripts is not a joy because of the way that they're kind of like in this separate environment. The debugger kind of gets a little confused when you try to step through them. So what we do is we end up, all of these calls end up really just calling ipc.send, and so we send them up to the parent renderer process. So that makes it easier to debug because we just get messages that then we look at and see the actual implementation that can step through and stuff like that. So here's the Slack Windows app. Let me move it over here. This is the Slack Windows app running on a Mac because I just built it on Mac, and so I got a Mac app out of it. And if I build it on Windows, then I get a Windows app. And if I build it on Linux, then I get a Linux app. And so because I'm on Team Tiny Spec, I can go like this. Toggle developer tools. I need to switch to mirrored or else I will not be able to see anything. And I can do anything I want that I can do in a web page. So I can like see these animations. That's not a good example. Define a mention. There we go. So I can debug this like fading into the badge. And mark as red, it goes away. And so we can see in here that I've got all this stuff, but then the main content is this thing called WebView. So it's just a tag. And it's got all this stuff in it. Does all these crazy things. We set the user agent to a special user agent the web client will then recognize. And then here I set this attribute called preload. And so that's my script that runs before the page gets loaded that sets up all the APIs that I want to define. And so we see that there's like there's two DevTools windows, and so this one is for the outer one. So if I try to like inspect like, oh, I want to take a look at this input element, I get stuck, right? I can see that I have this object tag, just like Flash, and so I can't get into that. And so what I can do is on WebView itself, I can say open DevTools. It's actually already open. And so here's the DevTools that represents this interior WebView. And so this is the code for the Slack web app. And so I can poke around and see all like scripts and styles and stuff like that. And so it means we can update, if we can get away with it, we can add features by just updating the web app. And then if we need to add new APIs, we ship a new version of the desktop app. And you kind of get the benefits of both. So like, if you're really in a fix and you need to change something or fix something, or people are suddenly hitting this bug that's really important, you can't ship a desktop app that'll like update fast enough. Like even we put a lot of work into shipping updates that are really fast and in the background, and nobody ever it doesn't bug anyone, but it's still like a 2-day latency before people get the latest version. But with with remote content, you can update it instantly. So cool. I think that's all I got. I have no idea what I'm looking at on time. So yeah.